Next up, we're going to be talking about batch changes. Sourcegraph batch changes is a tool which automates the process of performing repetitive changes to code across a huge number of repositories. The beauty of batch changes is that it has the flexibility to perform simple, straightforward, and deterministic use cases like refactoring deprecated Java classes, but it also has the power to perform much more complex use cases and even incorporate agentic AI workflows as well. Today, I'm going to walk you through some of our common and classic batch change use cases so you can get a sense of how batch changes can simplify some of dev's most toilsome tasks that are crucial to a healthy code base, but often deprioritized due to lack of time and resources. First, let's talk about deterministic versus non-deterministic use cases. Remember, deterministic means that the same outcome will be produced every time given the same input. Agentic or generative AI is non-deterministic, meaning each output will always vary slightly, even if you give the same input or the same prompt each time. It's important to understand this difference because there are times when introducing AI to a workflow could actually produce worse results than a simple or deterministic script. So let's look at some of those common deterministic use cases. What you're seeing here are example batch specs. These are the YAML files that contain the scripts and details needed to make a batch change. We'll get more into the mechanics of how a batch change works later, but for now, just know that these batch specs represent the three most common use cases that should make your ears perk up if you're on a call and a prospect is talking about code modernization, migration, or refactoring projects. So first, there are configuration changes. Updating CI build and configuration files across many repositories can be slow and repetitive for a few main reasons. For one, almost every repo will have its own structure. So oftentimes config files live in slightly different paths or use different naming conventions, and hunting down where each file lives can be time consuming. Also consider that some organizations can have hundreds or even thousands of repos, so making a small change like bumping a dependency version or changing a base image can take hours or even days of toilsome repetitive work. These files are also very sensitive to breaking changes, as a small typo, like a wrong indentation or a version mismatch, can cause build scripts to fail. So therefore, this is an excellent use case for batch changes to make a simple script, to make large-scale config changes, or in this example, update authentication in their CI pipeline. Next, there are refactoring changes. Like I mentioned earlier, there are times when small, straightforward changes need to be made across millions of lines of code. Oftentimes, these are language-specific changes that require you to find an old deprecated class, method, or function and replace it with a new, more efficient version. In the example shown here, this batch spec is referencing a tool called Combi to find and replace this fmt.sprintf function, which is basically a catch-all formatting engine that can handle formatting all different kinds of data types, with a cleaner ITOA function that is explicitly designed for converting integers to strings. So using this ITOA function instead is going to be faster and more efficient, but finding every instance where this function is being used and then replacing it with a new function is, as you can imagine, extremely tedious without batch changes. Lastly, one of the most valuable use cases for batch changes is the ability to find and fix security vulnerabilities. In the example batch spec here, it's actually using a static analysis tool called Dockerlint that will scan Docker files for common issues, bad practices, and security risks. One of the key checks is ensuring that you're pinning your base image, or in other words, you're specifying an exact immutable version, not a floating or an automatically updating one. In the script here, we're looking for any Docker file that has the tag latest because that means it's pulling a mutable version that could change over time, and we don't want our CI builds to be non-deterministic or unpredictable. Another common example we often give is Log4j. This was a Java-based logging library that had a critical vulnerability that allowed remote attackers to execute code on systems using certain versions of this library. With a CVE like this, time is everything. And while some companies work through Christmas trying to find and fix this across their entire code base, customers of Sourcegraph like Nutanix handled it in minutes. So in sum, anytime that you're making a pattern change across multiple repositories, batch changes can reduce hours, days, or weeks of work into a matter of minutes. It's also important to note that it's very flexible in terms of what you can script, and all kinds of tools can be leveraged within a batch change, like we saw with Combi and Dockerlint. This ability for batch changes to leverage third-party tools is important because it's ultimately how we can incorporate agentic AI into batch changes, which we'll get into next.